This video will discuss how to calculate the standard deviation and variance using the Casio fx-CG50. The standard deviation is a number that measures how far data values are from their mean. The standard deviation provides a numerical measure of the overall amount of variation in a dataset and can be used to determine whether a particular data value is close to or far from the mean. The example we have on the screen asks us to calculate the sample variance and standard deviation, and they give us a couple of sample values. As you'll see, these are pretty simple numbers. They are 1, 2, 3, 4, 5, 6, 7. If we were to do this by hand, we would have to find the mean in order to find how much the overall amount of variation from the mean is. We're not going to do this by hand, but we'll still talk about that at the end. In order to enter these into the Casio calculator, we will press the menu button, which will bring up this main menu. And from here, we will either select number 2, statistics, or you can just press the number 2. Now we have some other data values in here, so we're going to clear the lists. We'll use the right arrow under F6, press F4 to delete all, and then F1 to delete the list. Now my list is empty, so I will enter in the data values into list 1. I'd suggest you pause the video and do the same on your end. Now we're going to press F6 twice to go back to the main menu, and we're going to press F2 to calculate. Now we only have one variable here. It's just one variable, statistics, that we're going to calculate. In a prior example, we may have used a frequency list. There is no frequency list for this example, but you'll see here the one variable frequency is set to list 2. My list 2 is blank, so I'm going to make sure that I go down to the frequency and press 1 for F1. Basically, that's just saying that each value occurs only once, and we've already listed it that way in list 1. Press exit once, and then press F1 for one variable statistics. And from here, you'll see we have both the population and sample standard deviation. So the sample standard deviation is 2.1602. We'll round this to whatever place values you're asked to round it to in the question. In this case, we'll just round it to 2 place values. So the sample variance is just the squared value of the standard deviation. If we were to calculate the standard deviation by hand, we would need to find the mean, which in this case is 4, and we would try to find the deviations from the mean. There's another video that I've created that shows this in detail. But basically, what we would do is we would take all of the deviations from the mean and square them to find the total deviation in squared units, and then we can divide it by n-1, or the sample size minus 1, and that would give us the sample variance. There might be a few homework questions that ask you to find the sample variance. So I'm going to show you 2 ways of finding the sample variance. In the Casio calculator, we will press the menu button and then choose option 1, which is basically just the calculator function. From here, I'm going to press F2 to delete all, F1. That'll give us a nice blank clean screen to work with. So now we copied down the standard deviation before. The standard deviation was 2.160. I think there was a 2 after that. So we could type in 2.160 squared. It might be helpful to keep a few extra decimal places values here. But the more place values we keep, the better the approximation will be for the sample variance. Again, the sample variance is just the squared value of the standard deviation. So find the standard deviation and square it. And we'll get that this is 4.6656, and then you could round this to whatever place value you need to. We could also use another program within the calculator which allows us to enter any variable that we've calculated. So we will press the vars button for a second way of calculating this. And then we can press F3 for stat. We'll bring up all of our stats values. And then from here, we're going to choose F5 for input because we've already entered these values. And you'll see that F3 is the sample standard deviation. There are a few other options that we could use here. We're going to use F3 for sample standard deviation. The calculator just puts a letter X next to it because we could also do this for two variable stats. And in that case, we would have SY, or the standard deviation of the Y variable. So in this case, we're going to select SX, the sample standard deviation for the X variable, and then press the squared button and execute, and we will get the exact value of the sample variance, which is 4.6 repeated. So you might see other ways of calculating the variance using these formulas and a table. Again, the easiest way is to use the calculator, find the standard deviation, and then square that value to find the sample variance. Again, the standard deviation is the letter S. This is for sample values. The standard deviation measures the typical change, or the expected variation, or the standard deviation from the mean. Larger variance or dispersion of data values leads to larger standard deviations. Now, if you needed to find the population standard deviation, we can do that in the same way by using sigma. The population standard deviation is sigma. It's a Greek letter. The Greek letters are always used for population variables. The regular alphabet letters are used for sample variables. And one thing that you'll notice about the population standard deviation is that it is always smaller than the sample standard deviation. So how will you know the difference? Well, within the question, it will tell you in some way, shape, or form whether the variables that we have values for are sample or population. In this case, we are given that this is a sample standard deviation and sample variance that we're trying to find. If, however, the question implies or tells you that we have population variables, we will use sigma. Now, generally speaking, in most examples and in most real-world examples, we won't have the population data. So this population standard deviation will rarely be used, but there might be a few homework and quiz questions based on this.